Good morning, everyone. Actually, good afternoon. I guess this is geometry, isn't it? And I wanted to talk about lesson 91. It's not actually a hard lesson, but if I were just looking at it in the book, I would freak out. So I just thought that to help maybe you calm down about it, I would go through the lesson with you. I don't think it's actually a very challenge. I don't think it's a very hard lesson, but it looks really weird and it looks like it's complicated. So let's talk about it. Um, we'll start by looking at the most commonly used trig identities, which are below here. This is in your book, first page of the lesson. Now they say you already know these, and I know I taught these to you in advanced math, so these should be familiar to you. The tangent theta equals sine theta over cosine theta, and that comes out of the unit circle, kind of. But if you play around with it, you can see that it does work. The other one is that sine squared plus cosine squared equals 1. And they do actually prove this to you in the book. The idea goes back to a basic unit circle. And so the hypotenuse is 1, and the x and y are sine and cosine. And then this is just Pythagorean theorem. The x side is the cosine squared, the y side is the sine squared, and that's going to equal the hypotenuse, which is 1 squared. I think you should remember that. If you don't, you can look through their proof. It's fairly straightforward. And you did this back in, I think it's advanced math, maybe even Algebra 2. So sine squared equals plus cosine squared equals 1. So if, for example, they were to give you the cosine of x as 0.5, what is the sine of x? And so we can just plug it in. Okay, so sine squared x plus 0.5 squared, because the cosine of x is 0.5. Cosine squared, 0.5 squared equals 1. Subtract 0.5 squared from both sides, which 0.5 squared is 0.25. Take the square root, subtract, and take the square root, and we get the sine of x equals 0.866. So that's actually obviously a 30-60-90 triangle. I didn't do that on purpose. Okay, so you can see how you do that with numbers. But they want us to do this abstractly also. So for example, we start with that same sine squared x plus cosine squared x equals 1. Subtract cosine squared x from both sides, and then take the square root of both sides. And that, I know I have a horrible time with square root symbols, but the sine of x equals the square root of 1 minus cosine squared x. Now that's one way of doing this abstractly, and you can do a number of different things with that. Now the tangent of x equals sine x over cosine x. But if we want to change it so that it's all cosine and there's no sine, then we can say the tangent of x equals the square root of 1 minus the cosine squared of x divided by cosine x. So if somebody is giving you cosine x, you can directly find sine x from the cosine and tangent x directly from the cosine. And this is where they were going with this, and this is where they get to this chart, which is on the next page. And so the way this works, so you pick the first column. In the first column, you know the sign. Okay, you've been given the sign, whatever that is. It may be a number, however they gave it to you, you know the sign. Well, then you know the cosine is the square root of 1 minus sine squared theta, and the tangent is sine theta divided by the square root of 1 minus sine squared theta. If you know the cosine, then you can find the sine and the tangent. This is in the second column. You know the cosine in the second column. And then the first row you can find the sine, second row you can find the cosine, you already have that. Third row you can find the tangent. Third column, you know the tangent, so you can find the sine, tangent theta divided by the square root of 1 plus tangent theta. I'm guessing, no, that's right. And then cosine is 1 over the square root of 1 plus tangent squared theta, and then tangent theta just is tangent theta. So the point is, what they're doing in this lesson is showing you that if you know any one of those three trig identities, there's relationships between them so that you can find the others. And they're going to do some fun stuff with this. But anyway, I just wanted to go over that with you because, as I said, I think it looks strange. It's really not that bad, but I think it does look strange. If you have any additional questions, feel free to text me or call me, and I'll try to help you. All right, well, have a good day.